Hello guys, let's start with the today's section on minimum cost spanning tree. This topic is concerned with the greedy algorithms. So I will continue my lecture series on algorithms and problem solving. So before understanding the concept of minimum cost spanning tree, let me give you some idea about what is a spanning tree actually. So if I have a connected subgraph S of a given graph G, this subgraph S is said to be a spanning tree if and only if this S should contain all the vertices. This is the first condition, and this edge should have n minus 1 edges in the G, that is a given graph, which contain n vertices. So for a graph, or this also called as a subgraph, is a spanning tree S if it contain all the vertices in the graph and it contain n minus 1 edges. We have different types of graphs. The graphs can broadly be divided into two parts. The graph which contain a set of vertices and edges, it can be divided into a simple graph or a multi-graph. Simple graph are those graphs which does not contain any loops or does not have any multiple edges. Like, as we can see that this graph does not have any multiple edges or does not have any loop, so this is my simple graph. Similarly, this graph is also a simple graph. Wherever this graph is not a simple graph, this is a multi-graph, because I have a loop at this node and this graph also have multiple edges. So multiple edges means between two vertices we have multiple edges defined. Okay, now look at this graph. If graph only contain all the vertices, no edges, then this type of graph is called null graph. So if I have the set of vertices and the edges set is not defined, then this graph is called a null graph. Okay, now there are few more points regarding this spanning tree. We have degree of vertex is defined as a number of edges that are incident on that vertex. For any vertex, if the degree of vertex is 0, then the vertex is called isolated vertex. So a vertex is called isolated if the degree of vertex is 0. If every vertex is isolated vertex, then we call the graph as a null graph. As we see earlier in the previous slide, and the graph is called null graph when the degree of each vertex is 0, means there is no edges in the graph, and we call that graph as a null graph. If in a given graph every vertex is adjacent to another vertex, means if there is a path from one vertex to any other vertex, there is a direct path from one vertex to another vertex, then that graph is called complete graph. So this is a complete graph when we have 4 vertices. I say if a graph is complete with the 4 vertices, I call this graph as a K4. So K4 is a graph in which 4 vertices are there, and this graph is also called K4 graph, which is a complete graph having 6 edges. K4 graph is having 6 edges and 4 vertices. Okay, so this is a complete graph. Now, complete graphs, in a given graph, if the degree of every vertex is same and it is provided that it is a complete graph, then that graph is a regular graph. If every vertex have a same degree, then that graph is called a regular graph. So suppose let's consider the previous K4 graph. K4 is a 3 regular graph because every vertex have a degree 3. Now this vertex is also have a degree 3. This also have a degree 3. How the degree is 3? Because at this vertex 3 edges are incident. Every vertex have 3 edges that are incident on it. Okay, so K4 graph is a 3 regular graph. Similarly, if I have K5 graph, then K5 is a graph with complete graph with 5 vertices, then I call it as a 4 regular graph. Why 4 regular graph? Because the degree of each vertex here is 4 and the degree of each vertex is similar. So, this K5 complete graph, it have 4 regular graph and it contains 10 edges. In K4 complete graph, 6 edges are there and it is 3 regular graph. Okay. So, you can find out the number of edges by finding the relation, like by calculating the formula between the number of vertices. So, the number of edges can be given by, if we have n vertices, then it will be given by n into n minus by 2. So, this is the formula to calculate the number of edges in a given graph. Like in this graph, the number of edges 4 minus 3 by 2, that is 6. Similarly, for this graph, it is 5 minus 4 by 2, that is 10. Similarly, we can calculate the edges in other complete graphs. So, this formula is applicable only to the complete graph. Okay. Now, if I have n vertices, so if I have 4 vertices, so 4 vertices I have 4 into 3 by 2 means 6 edges are there, and based on these 6 edges, how many types of simple graphs are possible? So, if I have 6 edges given, then I can connect those 6 edges into 2 to the power 6 types of combinations. 2 to the power n means 2 to the power number of edges, how many maximum number of edges are there. So, by that I can get the total maximum possible simple graphs if the number of vertices are given. So, in a generalized way, if I have n vertices, then the maximum edges that can be possible, because the complete graph contains the maximum edges. So, the maximum edges that can be possible is n into n minus 1 by 2, and the maximum simple graph that can be possible is 2 to the power n into n minus 1 by 2. So, this is for the general case, how many maximum number of subclass are possible if the number of vertices are given, and how many number of maximum edges are possible if n is given. Now, next is what is a connected graph? So, these are the some of the terms which will be used for finding out the spanning tree. So, a connected graph is a graph if in a given graph we have a path between two vertices. So, if there exists a path between any two vertices in a given graph, we call that the graph is connected. Okay. Next is, suppose, see this, there is a graph G. So, this is a connected graph because between each two vertices I can find a path. Similarly, in this, all pair of vertices have a path. So, a spanning tree, we know the spanning tree contains all the vertices and we have n minus 1 edges. So, let us construct a spanning tree for a K4 graph. K4 is a complete graph with 4 vertices. So, the number of spanning tree that can be possible are already drawn here. So, here I remove this edge and these two edges. So, if I have 4 vertices, 3 edges must be there. So, these graph contain only 3 edges and all the combinations are, which is shown here, is the combination of those 3 edges. How you can connect those 3 edges? So for the K4 connected graph, I have 16 minimum spanning tree possible. So K4 contain 16 spanning tree that can be rewritten as 4 into 4 to the power 4 minus 2, and if I have K5 that contain 125 spanning trees, that can be written as 5 to the power 5 minus 2. So if I have a Kn, that is a n vertices complete connected graph, then I can have n to the power n minus 2 spanning tree that can be possible. So you can calculate the total number of spanning tree by this formula, and it is given that if n is given to you, then you can say that this graph contain n to the power n minus 2 number of spanning trees. Now let's take another example. What is the number of spanning tree in the following graph? So this graph is not complete. The point here is, or the trick here is, this graph is not complete. When the graph is not complete, it is not very easy to decide how many number of spanning trees are possible. So here I just drawn the 4 possible configuration of a spanning tree that can be extracted from this graph by removing any of the edge in the given graph. But it is always desirable to apply the Kirchhoffs theorem if the graph which is given to you is not a complete graph. So let's understand the Kirchhoffs theorem. What Kirchhoffs theorem says, or how the Kirchhoffs theorem can find out the number of minimum cost spanning tree. So Kirchhoffs theorem says that if adjacency matrix A is given for any graph G, so A is a adjacency matrix, and G is a given graph, then we have to obtain a matrix M. We have to obtain a matrix M by A. So how we obtain it? We are changing all the diagonal elements of the A to 1. If the diagonal elements are 1s, then we convert it to minus 1s, and all the diagonal elements zeros into its equal degree. So the number of spanning tree of G is the cofactor of M. So I just create a matrix M from the given adjacency matrix A, and then calculate the number of spanning trees are given by cofactor of this M. Okay, so let's take an example and try to understand this concept. Suppose adjacency matrix is which is given to you is suppose I have 4 vertices in my graph, V1, V2, V3 and V4. For the first row, the value of V1 to V1 is 0, V1 to V2 is suppose 1, then V1 to V3 is 0, and V1 to V4 is 1. So I also denote here V1, V2, V3 and V4. Similarly, I just initialize all other values in this matrix: 1, 0, 1, 1, then 0, 1, 0, 1, and 1, 1, 1 and 0. So this is the Kirchhoffs theorem. So all diagonal elements are 0. Why? Because I apply the Kirchhoffs theorem on simple graphs, and simple graphs does not contain any loop. So a graph is given. Suppose the graph which is given is like we have 4 vertices which is connected, okay, via this. So here it is V1, V2, V3 and V4. This is the given graph, okay, and this is the adjacency matrix of this graph. Now I have to calculate the M. m value. So for calculating the m value, first thing is replace all ones in the graph to minus 1. So let us initialize the m with a, and the changes which is applied here is all ones are replaced by minus 1. So I just okay, I just rewrite the values. So 0 minus 1 0 minus 1, then minus 1 0 minus 1 minus 1, then 0 and minus 1 0 minus 1, and minus 1 minus 1 minus 1 and 0. This is the first step. Sorry, this is the first step. Then in place of 0 in the diagonal elements, we just replace it with the degree of the vertices. Okay, so the next iteration of constructing the value of m is I just replace the value of diagonal element. So it is a v1. So degree of v1 here I can find out from the graph, it is 2. So I just replaced 2. Rest of the thing is kept as it is. I just only change the diagonal elements and with the degree of, so second diagonal element is replaced with the degree of v2, and the degree of v2 is 3. Then the rest of the elements in second row is same. Similarly, third row, the value of the degree of v3 is 2. So just write here 2, and in the fourth row all the minus 1, and the degree of the fourth node is 3. So replace it with the 3. Now this is my diagonal elements. Now I calculate the cofactor of m, which is given by minus 1 to the power row plus column, so that is r plus c. Now I have here how many rows and how many columns are there. So if I take a cofactor against this matrix, so I just skip first row and first column. So this would be 1 plus 1, and I write the sub matrix here 3 minus 1 minus 1 minus 1 2, sorry, 2 is a positive, 2 minus 1, and then again minus 1 minus 1 and 3. So this is the cofactor matrix. Now I calculate the cofactor as this would become minus 1 to the power 2 into 3 into 6 minus 1 plus 1 into minus 3 minus 1 plus and it is going to be minus 1 into 1 plus 2. Okay, now the outcome of this was nothing but 8. So I can have 8 spanning tree possible if I apply the any algorithm of minimum spanning tree on this graph G, which is given in this question. So this graph contain how many spanning tree? This graph G contain 8 spanning trees. Okay, now you can also apply I insist you to solve the question yourself. So I give you the problem. So suppose if this is a v1 vertex, this is, or you can say that suppose this is v4, it is v1, then we have v2, then we have v3, all are connected, and there is another vertex v5 which is connected to v3 and v2. This is the given graph. Now you can find out the adjacency matrix easily for this graph. Then find out the matrix M by the defined rules. Then find out the cofactor of M. The cofactor of M will give you the number of spanning tree for this graph. Okay, so I think you have learned about the Kirchhoffs theorem very well. Now to finding out the minimum cost spanning tree, because the main topic here is finding out the minimum cost spanning tree. We have learned about what is spanning tree. Now minimum cost spanning tree, so I just write the topic minimum cost spanning tree is nothing but a spanning tree with the minimum cost. So if a graph is given to you 1, 2, 4, and suppose here it is 3, and the if this is a connected graph, complete graph, and the weight for the each edge is given. So suppose it is 25, it is 50, then it is 40, then it is 30, and it is 20. So this is a connected undirected weighted graph. I can say that it is a connected undirected weighted graph. So for this graph I can draw number of minimum spanning trees. So we can find out the total number of spanning tree. So if I have a complete graph K4, then how many spanning trees are possible? 4 into 3 by 2 n into n minus 1 by 2. So it is nothing but 6 spanning trees that are possible. Among those 6 spanning trees, we have to select the spanning tree with the minimum cost. So suppose the first spanning tree can be drawn as this one. So this contain the edge weight as 20, this contain the edge weight as 10, this contain the edge weight as 50, and the cost for this minimum spanning tree is 80. Similarly, I can draw another spanning tree for the same graph. Now this is 40, this is 50, and this is 20, and the cost for this minimum spanning tree is 120. Similarly, for this one, if I choose this spanning tree, then it is 30, 20, 10. The cost would be comes as 60. Similarly, if I choose the graph as this one, and the cost for these edges are 25, 10, and 20. So the cost for this one is 55. Similarly, one more point, so one more tree can be drawn like this, and the cost is 30 here, cost is 50 here, cost is 10 here. So the total number of cost is 90. So we do some hit and trial basis and now calculate the cost for each of the spanning tree. We have to select the minimum cost spanning tree, means the tree which is have a minimum cost is selected as a minimum cost spanning. So for this combination, this is my minimum cost spanning tree. So there are various algorithms proposed by proposed in the Corman for finding out the minimum cost spanning tree. We have to study only two important algorithms for finding out the minimum cost spanning tree. So the first one is Kruskal's algorithm, and the second one is Prim's algorithm. These two algorithms are generally used to find out the minimum cost spanning tree. So let us take an example and try to understand the concept of these two algorithms. So it is better to cover this these two algorithms in a next lecture. Thank you for watching this video. You can like, comment your questions, and you can also share this video so that others can also get benefited from the content. Thank you very much for watching this.